In this problem, I'm asked to find the maximum height, the time of flight, and the range for a projectile fired from a cannon at 18 meters per second at an angle of 50 degrees above the horizon. The first thing to do is break up my initial velocity into x and y components. I'm going to make anything going to the right be positive x direction, and anything going upward be the positive y direction. So my velocity in the x direction, which doesn't change because the acceleration due to gravity is downward and there's no other acceleration in this problem, is going to be 18 meters per second times the cosine of 50 degrees. If I were to make that velocity of 18 meters per second, if I broke it down to its components, the x would be the adjacent side to the angle, the y would be the opposite. So the x gets cosine, and the v initial and the y would be 18 meters per second times the sine of 50 degrees. Alright, so I'll plug that into my calculator. If you're not getting the right answers, check to see that you're in degrees and not in radians. So I get 11.6 meters per second in the x, and 13.8 meters per second in the y. Alright, now the rest of the given that I know. My acceleration in the y is negative 9.81 meters per second squared. Negative because I defined upward as my positive direction. I'm going to say v final in the y is 0 meters per second, but I'll be careful because I mean that over here the velocity in the y is 0. It does not go up or down at that exact point. And so if I wanted to find something for the whole problem, I'll have to double it from the first half. So for example, the time it takes to go from the cannon to up here is half the time it takes to go from the cannon up to here and back down to the ground. So if I wanted to find time, we'll do that first. I can use the y direction. Vf in the y is equal to vi in the y plus at. So 0 equals 13.8 minus 9.81 t, and t is equal to 1.4. But I'm going to be careful because that was the time it took to go from an upward speed of 13.8 when it was shot from the cannon to an upward speed of 0 right up here. So that's the time it was going up for. To get t total, I'll have to multiply this by 2, and I'll get 2.8 seconds. I could also find the maximum height by finding dy So I would choose to use Vf squared equals Vi squared plus 2AD. There are several other ways you can do it using time, but if you're going to use time, make sure you use 1.4 seconds. That was the time it reached its maximum height. So 0 squared, this is all in the y direction, equals 13.8 squared plus 2, negative 9.81 d, and d comes out to be, let's see, 13.8 squared. Bring it to the other side, it becomes negative, divide by 19.6, I get 9.7 meters. And the last thing I'm going to find is the range. I can use Vx equals dx over t to solve that. The velocity in the x is 11.6. The time it's moving over is the entire 2.8 seconds. And so dx is equal to 2.8 times 116 is 32.5 meters.